Hello everyone, welcome to my programming club. Today we will be solving another daily lead code challenge, and the challenge name is minimize maximum difference of pairs. So the challenge statement goes like this: you are given a zero indexed integer array nums and an integer p. Find the p pairs of indices of nums array such that the maximum difference amongst all the pairs is minimized. Uh, what the problem statement is saying is you will be given integer array nums and you will be given another integer which is p. You have to form p pairs. Number of pairs will be p. So from where these pairs will be formed, this pairs will be formed from the indices of nums array. I hope till now it's clear to you. And what we have to do is, now let's say for example it was something like that. If I take index 0 and index or let's say I take index 1 and index 2, if I form a pair of indices index 1 comma 2, what is the number at this index? It is 2. What is the number of that at this index? It is 5. What is their absolute difference? It is 3. So it is a pair. These two are indices. So among all the p pairs that you will be forming, p pairs, you have to check what is maximum difference among those pairs. Maximum difference between the indices of a single pair when considered. The number representing the number at those indices. This is the difference that we are talking about. So what we have to do is we have to minimize this maximum difference. Minimize max difference among pairs, among p pairs. And we have to tell what will be the minimum maximum difference among p pairs. What will be the minimum maximum difference among p pairs. This is what you have to return. Also, it is mentioned to ensure that no index appears more than once amongst the p pairs. So it cannot be like this. If you take a pair to 1 comma 2, you cannot take a pair 1 comma 5. Since this index 1 is appearing twice, index 1 is appearing more than once. Among pairs. That's the p pairs. So this is not allowed. Repetition of index among p pairs is not allowed. So I hope you are able to understand. And note that the pair of the elements at index I and j, let's consider that there is a pair with the index I and j, then the difference of that pair is the absolute difference of numbers at those indices, which I have just told you here. This is the difference. The numbers at those indices and their absolute difference is the difference for a pair, for one pair considered. So we have to return the minimum maximum difference among all p pairs when we define the maximum of an empty set to be 0. So if it's an empty set, then the maximum will be 0. So the length of the what are the constraints? The length of the nums array is given of order 10 raised to power 5. Length of nums array is given of order 10 raised to power 5, and nums every element in the nums array is of order 10 raised to power 9. Every element of nums array is of order 10 raised to power 9, and the number of pairs that you will be asked to form will be always either than lesser than or equal to it will always be greater than or equal to 0, since the number of pairs that you can be asked to form can be 0, and it can be either lesser than or equal to length of nums array divided by 2. So I hope it's clear to you. These are the constraints. Now what will the brute force way to solve this problem? Now, since it is being said that you have to minimize the maximum difference possible, so what you can do is, first of all, you can think of uh, well, it's not entirely brute force. If you will think greedily, and then what you will do is you will sort the array. Let's say after sorting the array, it becomes something like this. So you should notice that the difference between two consecutive elements is the minimum possible among those two elements. If you take 1 and 2, what will be the minimum difference? It is the minimum difference indeed possible, and this will be minimized, so the consecutive distance will be minimized. If you decide to form pairs with two consecutive elements, then the difference that will come out will be minimized. But it will not be. It will depend upon your choice. For example, if let's say you decide to form a pair of 1 comma 2, or you can also decide to form a pair of 2 comma 2. So here you should notice that 1 minus 2 absolute difference will be 1, and 2 minus 2 absolute difference will be 0. So this pair is more favorable since we have to minimize the difference, more favorable to minimize maximum difference. So what is essentially happening is for each pair, for each number, For each number, you are having two choices. You can either take comma pair with the previous number. Let me quickly change the color. Uh, you can comma pair with previous number or comma pair with next number. So for this number, let's consider this. You are having two choices. Either you can form a pair with previous number. This is the previous number, and this is the next number. So you for a considered number, or say index, you are having two choices. Either it will be previous index or it will be the next index with whom you will be forming the pair. This thing you will be doing after sorting the array. Since it will ease our work to minimize maximum difference. So these are the possible ways a number can form a pair. So for every index, let's say for the last index and this last index and the first index, these will be not present. Previous and the next indices will be not present. Otherwise, it will be fine. So what you can say is essentially for every index, let's take these indices also. It will not matter much. For every index, you will have two choices to form pairs. And how many number of indices are there? There are n indices. So 2 into 2 into 2 goes on till n times. So 2 raised to power n choices. And what 2 raised to power n here is? N is of order 10 raised to power 5. So this will be a very huge number. Huge number of operations. This will be all the possible p pairs generated. All possible set of p pairs to minimize maximum difference. It will be very much greater than 10 raised to power 8 operations. Allowed in 1 second. Those of you who are new to this concept, what I can tell you is in 1 second you are allowed 10 raised to power 8 operations, and if the number of operations in your program uh, either reaches equal to 10 raised to power 8 operations or exceeds it, so the number of operations of your program, your solution, either reaches equal to or greater than 10 raised to power 8 operation, then you may get a TLE, time limit exceeded, and your solution will not be accepted. So this brute force way of generating all possible P pairs to minimize the maximum difference will not work. We have to optimize. What we can do is, instead of checking for every possible uh, set of pairs generated, what we will do, we can check for what uh, check for the maximum, minimum, maximum difference possible. So what will the maximum, what will the difference lie between? What will the range of the difference between pairs? It will be nothing but, since it's mentioned that uh, nums element in the nums array is of maximum size 10 raised to power 9. So the difference can range from 0 to 10 raised to power 9. This difference, it can range from 0 to 10 raised to power 9. So what you can do is, you will run a loop. You will run a loop from 0 to 10 raised to power 9, and then you will run another nested loop. You will iterate over the nums array to check if with current difference it is possible to form a number of pairs greater than or equal to P. So what is the current difference? It will the value for which we will be iterating over this. So current difference will lie in this range. Current difference will lie in this range. So you can this loop will represent difference, and this will to check feasibility of difference. To check feasibility of difference. How you will be checking the feasibility of difference? If it is possible to form number of pairs greater than or equal to P with this difference as the maximum difference possible. So the difference between the numbers can be lesser than or equal to than this difference, but it cannot be greater than this difference. So if it is possible, uh, you will return minimum of feasible differences, minimum of all such differences. Now, what will be the number of operations that will be required to do? So it will be 10 raised to power 9 for this loop will run 10 raised to power 9 times. And what will be the maximum number of times this loop will be running? It will be nothing but it is equal to length of nums array. and whose what is the maximum length of the nums array that can be possible? It is 10 raised to power 5, and they are 10 raised to power 14. Now this 10 raised to power 14 is lesser than 2 into 10 raised to power 5. This will be the second brute force. Let's call this first optimization over brute force. First optimization over brute force. Now how we will be doing the second optimization, since it is also greater than 10 raised to power 8 operations. And those of you who are still confused what this 10 raised to power 8 operations is, I will provide a link of article describing how the time complexity of accepted solution varies according to input size. I will provide a link for article describing this. Basically, in 1 second, 10 raised to power 8 operations are allowed, and the number of operations of your solution exceeds or becomes equal to this, then you will get a TLE. So you will need further optimization. So you should further optimize. Now, what we can change in this approach, since this loop will definitely run to check the feasibility, we cannot change this. We cannot do optimization here. But we can do optimization here. We can do optimization on picking the current difference from the range possible. What optimization we will do? We will apply binary search. Apply binary search. What will binary search for? Let me quickly erase the board. Yeah. What will be binary search for? For picking current maximum difference from range. What is the range? It is nothing but this range, 0 to 10 raised to power 9. So we can apply binary search. So this number of executions of this loop will be reduced to log 10 raised to power 9, which is not a big number. And so the total number of operations will be reduced to log of 10 raised to power 9 into 10 raised to power 5, which is lesser than 10 raised to power 8 operations. So your solution will be accepted. Our time complexity will be O of order of nums of 5 into order of nums length. Basically, it is the maximum value possible for the element in nums array, and it will be the it will be the log of this maximum value possible into length of the nums array. So let me write clearly. It will be O of log of order of element in nums array into order of size of nums array. I hope it's clear to you. It will be nothing but log of 10 raised to power 9 into n, if n denotes the size of the nums array. So it will be this, and your solution will be accepted. So yeah, that's pretty much it. Now let's quickly move into the coding part of the solution. Now let me quickly zoom out so that you will be able to see a larger portion of the code. Yeah, it should be fine. What we have done is we have sorted the array to greedily reduce maximum difference possible among p pairs to some extent. So then you will check for this range will be the range. This range will be the range to pick current maximum difference possible among p pairs. So you will this will be the current maximum difference that you will be checking for the feasibility. Pardon me if some spelling is incorrect. I hope it's not hampering your learning of the approach. So checking for the feasibility of the current maximum difference proposed. So we will check if this difference is possible. What we will check if this with this difference as the maximum difference, with this difference as the maximum difference among p pairs is it possible to form number of pairs greater than or equal to p. So this function will be checking for, and you were basically having two choices. Either you could have included the previous number, you could have included the current number. If the current difference is lesser than or equal to the maximum difference, then you will skip the next index. If the difference of current num with next num is less than or equal to max difference, then a pair is formed and jump to next pair formation. So you will increase the index and you will increase the number of pairs formed. It is the p count. It will represent number of pairs formed. Increase the number of pairs formed. So at last you will be check whether the number of pairs formed is greater than or equal to p. Then if it's true, then you will reduce the maximum difference. You will check for the one lesser maximum difference. Reduce your range to half. So this is a pretty much standard binary search. Those of you who are new to binary search, I will be providing a link for article describing binary search. And that's of the problem of that's the solution of the problem. And you will return the maximum difference possible. So yeah, and the code will be available in the GitHub repository. It will be available in both C++ and Java. Thank you for watching. Thanks.